invite Mr. KVS Dilip Garu to take the session. Today, he would like to discuss about merging of data analytics and IoT for business applications. Sir, could you please take the session?
Yeah, thank you for the kind introduction. So before I begin, I just want to check with the participants if they're able to hear me, if you can type yes on the chat. So the way I would like to conduct this session is, I would like to have lots of participation from the participants. So I'll be asking some questions in between. It requires very short answers, not, anyways, kind of, no need to be afraid or anything like that. Just directly answer your questions on the chat. So if I can have, just a quick check if everybody is on, can I have a yes on the chat, please? In the meanwhile, I'll just share my screen.
Yes, sir.
I would request others who are, not talking, if you can go on mute, it will be great. Thank you. Okay. Just wanted to check everybody is able to see this presentation, right?
Yes, sir. We are able to see.
Okay. Okay, great. Awesome. Okay, so let's begin. Just give me a minute. I'm just setting up some few things. Okay, no problem. Okay, cool. Today's topic would be merging IoT and data analytics for business. And for this topic, I just want to set the context very clearly over here. First thing, I'm going to talk more about data analytics than IoT. So I'll just briefly introduce the context of why IoT is important, but in this talk, I'll be focused more on data analytics or data science and how it is useful for business. So that is where the focus of this talk predominantly is going to be. And keep it. I'll keep it really interactive. In between, I'll pause. I'll come back to the main Teams chat and see if there are some questions overall, so that I very clearly understand that you're all on the same page. Feel free to interrupt me, ask me any questions that you want. Let us keep it very interactive overall. Okay, a little bit more about me. I think the introduction kind of talks about what I do. Just want to give a little more insight into what I am doing at Grey Atom. So, what I typically do is I design the complete learner experience right from onboarding to their job. And I also talk to a lot of industry partners to understand what is it that they require in the people who are joining their companies, and we try to develop those skills right in the students so that they are well prepared for the jobs ahead. So I speak to a lot of people in the industries day in and day out. So because of that, I have this unique perspective of what people in industries really want. And because with that insights, we again try to redesign our programs so that people are industry ready when they enter the portals overall. So that's about me. About Grey Atom. So what Grey Atom does is we upskill people in emerging technologies like data science and full stack web development. So we do focused boot camps of around 6 months around in these programs, and at the end of 6 months, we get them to the different jobs and ensure that people with the right skills get the right jobs overall. So we have seen almost around 1,200 plus career transformations. So we have seen around 1,200 stories. Each story is very, very unique. And how it ties back to this is what is it that business really wants out of people so that they are benefited. So that is the important insight that I want to provide to this talk. So if you want to know more about us, Google about us, Gray Atom, and you will see what we are doing. Today's agenda. So first, I will briefly talk about data analytics and IoT a little bit. As I told, the focus of this talk is going to be data analytics, data science, and not too much on IoT, but I'll give the context as to why data analytics is important from IoT. Then I'll talk about what is data science and what is not data science. Then how business problems are solved using data science and why data science projects fail. So this is the rough agenda I'm thinking to car in the next 60 to 80 minutes, and post that I will leave some time for Q&A. Okay, so state of Internet of Things. So I hope some people would have seen this visual in some way or another. But typically, where is this opportunity for Internet of Things? Okay, so the main opportunity lies in these four sectors. One is agriculture, the ag tech. There is a lot of value creation due to Internet of Things. So say smart tractors, or smart irrigation systems, which actually try to measure the amount of moisture in the soil and then automatically trigger a sprinkler system. That could be one of the very good use cases of Internet of Things in agriculture. Humans and homes, I think anybody of you who has heard about Alexa, Google Home, or anything like that, you have a very clear idea of what it is in home. So anything like automation, security, health, fitness, we see a lot of opportunity there. Then, of course, factories, sensors, wherever you're putting a sensor, that is actually IoT. So your sensors, your equipment optimization, operations, all the factories use sensors, and also cities and vehicles, public health. For example, the sensors in Delhi would actually measure the air quality day in and day out and suggest that, okay, the air quality is becoming bad and we need to act upon it really soon. So if you see, the overall industry is almost like 3.9 to $11 trillion industries scope per annum by 2025. So that is the importance of IoT. Now, where does data analytics come into picture? So for data analytics, IoT is like a input to the data analytics. So what happens is the IoT devices or the sensors capture lots and lots and lots of information overall, and all of this information that is captured through different devices, it has to be analyzed to kind of give some insights back and say that, okay, now we need to do this action. So that intelligence, okay, so when you say Internet of Things, it's a sensor. It is a pure sensor which measures something and gives an output. But from the measurements, what actions to be taken, that intelligence is what data analytics provides. So if you see here, the data analytics in the center captures the input and then gives the output to the data monitoring applications, which then further send signals back to the IoT to kind of do some actions. Simple example, there is a moisture over here, and there is some other information of the weather. Combine both of this, you get some idea that, okay, I need to regulate my sprinkler system so that I can conserve water. So this intelligence that, okay, you need to regulate the sprinkler system here, that intelligence, that insight, your data analytics system is going to provide. So some of the barriers to Internet of Things or analytics system, so something that has really not helped this to scale, is one thing is security. Like, people are worried about the security aspects of if your data is so freely available, how vulnerable it is to hacking and hijacking of this data. Like companies, for the every company, this data is proprietary information. For a homeowner, there is a personal privacy involved. So how secure it is, that is a huge problem with respect to IoT. Then the IT OT integration, integrating the IoT systems, the information technology systems with the output systems, very, very important. Unclear return of investment. Okay, so yes, I'm going to put sensors everywhere, but how much is the investment I'm doing and what is the return of investment? So that is not very clear. Okay, so for example, for an agriculture use case for the farmer, he is only interested in seeing the grain, the output of the grain. Now, can you convince a farmer that because you put a sensor in the ground throughout and you invest some tens and thousands of rupees, you are going to get a better output? How can you convince that complete return of investment? So that is also a thing. And of course, farmer is a very small use case. When you go to huge industries, the investment goes into crores. So for the crores of investment that the companies are putting in, what is the returns people get? That is very important. Now, here is a tip for all of you to kind of, when you are teaching your students about anything with respect to data analytics, IoT, or business, it is very important to inculcate in them this ROI mindset that, okay, you are doing this, but what is the return of the investment? See, at the end of the day, business is investing in data analytics, they need returns. If they feel that prior investment they were not getting any returns, post investment they are getting almost the same returns as before, then there is no incentive for them to continue. So that mindset that, okay, what is the importance that the industry is getting becomes very important. Then interoperability, data portability, these are smaller issues, but more or less the top three issues are the main things why you don't see too much of IoT adoption. Okay, so now that you have understood the IoT sides of things and we have seen that the data analytics is like the middle layer which captures the data from IoT and processes it and gives out some information. Okay, now let us go deeper into the middle layer to understand what it does with the information passed on by the IoT devices and what is happening over here. So, number one, what is data science and machine learning? Okay, so what is data science and machine learning? Uh, can anybody take a stab at it? Data science and machine learning. If you guys want to tell briefly like what you understand of data science and machine learning, it will be awesome. Just giving you 2 minutes so that anybody can just talk about what data science and machine learning is. Don't worry about wrong answer, right answer, anything. Just tell me what you think you know about it. That's all. Okay, no problem. So let me kind of give you some perspective on data science and machine learning. So first thing, data science is the field of study that combines domain expertise, programming skills, and knowledge of mathematics and statistics to extract meaningful insights from data. Okay, so you have domain expertise, like which is the your own domain. Like suppose agriculture, that's the agriculture domain. If you are looking at a factory or manufacturing, it is a manufacturing domain. And if you are looking at finance, then you're looking at finance domain. Along with that, you need to have some kind of a programming skills with knowledge of mathematics and statistics to extract meaningful insights from data. If you strip away all the other items and you just focus on one thing, right? Say insights from data. Okay. If you are able to use data science to gather insights from data, that is more than sufficient. And if you are able to provide insights from data to provide value to business, that is the best thing that you could do. Okay. So machine learning is a subset of data science. The definition is again little complicated, but I hope you kind of get this a little bit. It's a science of getting computers to act without being explicitly programmed. So you have computers without getting them to do things without explicitly programmed. That is machine learning. Okay. Now I want to ask you a few questions over here. Would love it if you guys can respond for these questions. My first question is, how many of you are using smartphones? Anybody is using smartphones over here?
I guess everybody is using.
Okay, everybody's using. Awesome. So in the smartphones that you are using, has anybody used Google Assistant or Google
Yes,
Maps?
yes,
Great. Okay, awesome. So in Google Assistant and Google Maps, right? Have you seen this thing? Like when you are supposed to take a route, it shows you exactly the amount of time you are going to reach from one point to another. So have
Yes.
any of you used the system? Right. So have some of you observed that you might be traveling on the same route, but at different times when you're traveling, it tells you, okay, the timing that it shows keeps changing. Have you guys
Yes.
observed that? Yes. Yeah.
Yes.
So what happens there is the machine learning system in Google Maps, it captures the previous trips that you have made and the previous trips some people like you have made every time. For example, if a person A has gone from something like Hyderabad to Vizag, say once they traveled once during morning. Okay, then suddenly somebody has traveled from Hyderabad to somewhere between Vizag, which is Vijayawada, again sometime. So then, as more and more people keep traveling, that from this point to this point, I am traveling again and again and again, right? The system understands that, okay, this is what is happening. Another question, have any of you noticed this maroon marks on your maps when there is some kind of a traffic jam or something?
Yeah.
Okay, so now that happens when, the way it happens is everybody has a smartphone, and most of the smartphones, at least in India, have Google Maps, right? And then when you have multiple phones at a particular point, because everybody has Google Maps active, multiple points, and none of the mobile phones are moving, then what is the indication you're getting there? The indication is that there is some traffic jam that has happened. So earlier systems of Google used to ask people, if there's a traffic jam, enter that there's a traffic jam, and then they used to take care of things. But right now what they do is, just by tracking the phones, okay, they decide that, okay, there is a traffic jam or not a traffic jam. So once in South America, what people had done is they took a trolley and they put 100 mobile phones in that trolley and left it in the middle of the road. Then through another phone, they kind of checked the route. In little few minutes, what happened is, the particular point where the trolley was parked, the system showed that there was a huge traffic jam. It was like 100 vehicles have piled up. For actually, it was just 100 mobile phones which are not moving, but that is the assumption that your Google system is making. Okay, so coming back to data science and machine learning, beyond data science and machine learning, if you have to very clearly understand what is happening, previous data, like, it captures all the data that has happened previously and tries to predict what is going to happen in the future. That is what data science and machine learning does. So for the IoT use case, takes in all the data that the IoT system provides, and then from the IoT system, whatever data it tries to measure the output that is happening there, and then decides what action needs to be taken. So that is how data science and IoT systems kind of work together. So in the main difference between classical programming and machine learning is this: for classical programming, you have the data, you have the rules, combine the rules and the data, you get the answers. Okay. For machine learning, you have the data, you have the answers, combine the previous data and the answers, plug it in, and what you get as output is the rules. So the difference between classical programming and machine learning: classical programming, take in the rules, get the answers. Machine learning, take the previous answers and frame the rules, use these rules to predict the future answers. So that is how data science very clearly works. Okay, so let us go through some of the applications in data science. For example, one application could be there is a picture and there are human faces. So the application here is photo tagging. So whenever there is photo tagging happening, right, that is where machine learning is used. For those of you who are sharing photos in Facebook, sometimes you can see that your photo is automatically tagged. That's where machine learning is kind of working. Then a lot of use cases in fintech. So if you are using apps like Paytm, PhonePe, and other apps, so right now Paytm has started this loan process also. Like if you apply, you can even get loans through Paytm. So what they do, they have this model behind it. Okay, this is the user information. Will they repay the loan or will they not repay the loan? So based on that, loan approvals keep happening. Other things. So I hope all of you are using Google, and you're surfing on Google and doing search results. All of you are using YouTube, right? Anybody of you have seen ads being served to you while using Google, Facebook, or any other things? Any ads that you see? Yes. So in the ads that you see, right? Have you ever noticed this button? Is this ad relevant to you or not relevant to you? Have you seen that? Have you seen that particular button somewhere as you are browsing?
Yes, sir.
Great. So when you see those buttons, what it tries to do is those ads are actually being served through you via some machine learning predictions. So it is trying to see whether you really like the ad or not like the ad. And typically, if you click on an ad, the system will understand that you love the ad, and that's why you are you are clicking on this particular ads. And if you don't really like the ad, what happens is you don't typically go for the system. So that's how it overall works. So again, going back to other use cases, translation. So if anybody of you are interested, Google Translate, just check it. Type in an English sentence, you can translate it to any other sentence overall. So whenever this automatic translation is happening, that is machine learning. Then sensors, I think we talked a lot about sensors as to how preventive maintenance is happening. And this preventive maintenance is one of the major use cases of IoT. And of course, self-driving cars, where you have car camera, other sensors, and decide whether the car is moving or not moving. Okay, so I would like to type in one name over here on the chat. It is a company called Waymo. Check this company out. So they have some videos where they show exactly how their car is actually traveling through New York streets. But again, in Indian use case, if somebody is able to make a self-driving car, you should be getting the Nobel Prize, because for the Indian chaotic traffic that you have, you can never design a perfect system that will ensure that the car accidents are not happening. Okay, because we are the way we travel right on the roads. You have people cutting from left, you have people cutting from right, and if they decide that okay, accident is going to happen, we should stop the car immediately, the car would even move. Okay, so yeah, so those are the various applications of machine learning. So now I want to dispel some of the myths around machine learning. So we have discussed, okay, this is what machine learning can do, this is how the machine learning systems are designed. Let me take up one myth or some misconception regarding machine learning, and then decide about what it is. Number one, machines can learn autonomously. So whenever somebody says machines become autonomous systems, understand very clearly that that person is bluffing. So you cannot have an autonomous machine ever. Any machine, like even if you are doing 90% of your things automatically, there is a 10% factor that is necessary to kind of use the human intelligence to take decisions. Okay. For example, again, going back to the agriculture use case, right? Now, let me ask you these questions. So, the ground is somewhat wet, and there is a prediction that it is going to rain in the evening. Now, the sensor says that, okay, you know what, at 2 p.m., you should do another round of sprinkling of water. But you know for sure that at 4 p.m., it is going to rain again, right? At that point, what would you as a human do? Would you switch on your sprinkler at 2 p.m., or would you wait for the rain and then maybe switch on the sprinkler at 4 p.m.? So 2 p.m. or 4 p.m.? What is your idea? How would you take a decision over here?
I guess we'll sprinkle at 4 p.m.
4 p.m. Right, exactly. So, see, that's what the point I'm trying to make. The human decision is different from a machine decision because we think from various angles, while humans, like the machines, they think only on one angle. And why it is that? Because for the machine, you are only giving the data about the soil. You are not entering the climate data. That climate data is your head. So there are always take up any problem that you want. There are always multiple angles that machines would mesh, and that multiple angles the human has to make the judgment call. So whenever you are saying machine learning is something that you have completely autonomous, it does not. You always need to have a human intervention. Machine learning, data science can be applied to any task. Okay. So again, this is a problem. It cannot be applied to anything and everything. For some things, machine learning is not at all required. And little bit into the presentation, we will understand this aspect also clearly. The next myth is once the data is fed, the data science will give transformational insights. So this is what what happens is you think that I have all this sensor data that has come out through IoT. I plug it in a data science system that I have designed, and when I get the insights, they'll be so great that my system will work really smoothly, and the business will get a lot of money. So this is a very important misconception people are having, that when you have say you just put in data, you get in output and everything is good. It is not that simple. A human has to be looking at the inputs and outputs at every step of the process, and looking at the inputs and outputs, keep tuning the system. And once the system is giving good output, then you say that, okay, yes, now there is insights. Second, a human has to look at those insights and make a judgment call that, okay, what is it that is going to happen? One very good example in March 2020, when lockdown had happened, right? All the companies who were relying on information pre-March 2020 to make decisions, all of those decision systems were switched off, and they set up simple rules, collected new data from March to June, and then again they switched on their machine learning systems around June, July. And an example there is Zomato, Swiggy. When lockdown happened, the ways the restaurants were running, the ways the deliveries were happening, and all that completely changed overnight. So all the data that they had previously didn't really help them. So that time they switched off the system. They used simple rules to help their drivers, and then slowly they kind of collected new data and then tuned their system again. So again, data is fed, data science will give transformational insights. That is not the case. There is a lot of manual hard work and fine tuning that needs to be done for data science to give transformational insights. So for people who say that, okay, I have IoT data, I put it in data science, now I know what to do, that is a complete misconception that has to be removed from all the students, that they cannot think in that manner. Of course, this is the favorite myth. Data science will give rise to superhuman intelligence. I think previously three examples that I had given, I always said that there needs to be human judgment that is happening. So therefore, superhuman intelligence, good for movies, good for science fiction, good for entertainment, but practically it is not going to happen. Okay, so let us do a small exercise. Can you suggest to me some, if you can suggest to me some, uh, you know, application in IoT or something otherwise, and we will take that IoT application and apply to a flowchart to see if we can use data science to solve that problem or not. So any application, anything that you feel uses data, anything, be very random. I want you to suggest something. From your suggestion, we will learn whether machine learning is going to be applicable or not applicable. I'm giving you 1 minute. Think of it, propose to me something, and we will take it from there. Machine condition monitoring, very good example. I'll just wait for one or two more suggestions and we will take all of them at once.
Uh, in process execution in concurrent programming, resource request analyzation.
Resource request for concurrent programming. Great example.
Yes.
Any other? Yeah, please go ahead.
To avoid deadlocks prediction.
Deadlock prediction. Great. Any other suggestions? So we have got machine bottle filling on conveyor belt. Great. So thanks for all the three suggestions. So we'll start with that. So we have got three suggestions. One is machine condition monitoring. Second is deadlock prevention. And third is bottle filling on the conveyor belt. So let us start with the machine condition monitoring. So we have started over here. So now, first question you need to ask is, do you need automation for machine condition monitoring? Okay. So do you think you need automation for machine condition monitoring? Yes or no? What do you guys think? Do you think automation is going to help machine condition monitoring? Yes. So if you feel that automation is going to help, yes. So therefore you move ahead. Now, can you write down on paper all the possible rules that can occur in machine condition monitoring? Suppose you say, if the machine, suppose it's a machine which has some component of rotations per minute. So if you see that the rotations per minute is changing or dropping, increasing, fluctuating, then is the machine condition all right, not all right? Again, not a machine person, I'm just speculating over here. If you write all of the rules on paper, how many rules do you think can occur for machine condition monitoring? That is the next question. So can you just type in some number that you think at the top of your head? Again, take a rough number, like how many rules do you think you will make when you are monitoring a given machine? Think of all the inputs to the machine. There is an input, raw input to the machine. There is electricity to the machine. There is a mechanical machine. There are different parts for the machine. So if you take all the permutations and combinations, how many rules do you think it will happen? Okay. Speed, variation, vibration, temperature, power consumption, etc. So there are 4 factors. Now, the complication is either there is a speed variation or there's a speed variation plus this happening, or there is something and another thing happening. So there could be, if there are some, say, 10 factors that are available for a machine to kind of monitor, if you look at all the permutations and combinations that could happen within these 10 factors, you see that it is almost like, I think around 10 factorial, it's a 10C2. Okay, so 10 combination 2 is the number of rules that you will frame. So manually, can you program 10C2 rules? Yes or no?
No.
No, right? So that is where your answer is no, and you move ahead. That you have the rules, you can write them, but it is so much that you cannot code these rules. So you move ahead. Can you formulate your problems very, very clearly? As in, for the machine condition monitoring, Do you know exactly what is happening inside the machine that could cause failures? Yes, because you have designed the machine and the machine is running man-made, this thing is extremely clear. So therefore, it is yes. Then do you have data? Like, when a machine has failed earlier, do you have data as to why the machine failed at that particular point in time? The more data you have, that better. If you have data, you can move ahead. If you don't have data, you need to collect that data before you make a machine learning system. Next, do you have a regular pattern? Okay, so for regular pattern, that is, there are only few issues that are happening that are causing a machines to fail. Okay, so of all the rules, if you think about it, the point of failure to a machine are very few causes, and those few causes only keep repeating, and therefore you have a regular pattern that is happening, and therefore you say that yes, there is a regular pattern for my machine functioning. Then do you have meaningful features? By features as in, so those factors, those rules, speed variation, can you measure the speed of the machine? Can you measure the output of the machine? Can you measure the temperature at which the machine is operating? Is it getting overheated or is it maintaining similar? So those are the kind of things that I'm talking about. If the answer is yes, you move ahead. If the answer is no, for what features or what measurements you need to take, then you have to look for different data and you have to be able to capture that data. If you don't capture the data, there's no point doing this analysis. Then you understand whether you can measure the success or not. Okay, so what is a success criteria for a machine condition monitoring? Like when can you say that the machine monitoring is successful for me? You have designed this entire system which is going to predict when your machine is working or when your machine is about to fail. What is your success criteria over here? So think in this manner. Uh, Before I set up my system, I used to see maybe 4 failures every quarter. Like every 3 months, I used to see 4 failures. Post setting up my system, I am seeing 0 to 1 failure every quarter. Do you feel my system is successful? Yes, no? Yes, great. So in this case, your system is successful. Okay, so then because you can measure success, you say that, okay, this problem I can solve using machine learning. Okay, now let us quickly run to the other use cases. Other thing is deadlock avoidance. Okay, start. Do you need automation for deadlock avoidance? I need automation because manually I cannot remove a deadlock. It has to happen through some automation. Can you write the rules? Can you write the various rules when deadlock could occur? Now here, this is very tricky. You can't frame all the deadlock rules that are happening. It becomes very difficult because it is something that is happening inside the system with various processes that are running. And it's very difficult to kind of put your finger on what exactly is going wrong. Why? For the same resource, who are the multiple people competing? So do you have a very clear understanding of the various cases where deadlock is going to occur? So for me, deadlock can occur where there are multiple processes that are using the same resource. So if I can keep a count of all the resources that I'm allocating for my deadlock, I can keep a note of that. If I can keep all the different permutations and combinations, then I can use a rule-based system, simple system to avoid deadlocks. And actually, in real chips nowadays, in real CPUs, for deadlock they use very simple rules. Okay, but if you find that you are looking at a very huge system where you require some kind of machine learning, then you kind of go across this complete flowchart. For your personal systems, you don't require machine learning for deadlock avoidance. But for huge systems like mainframes or supercomputers, because there is a lot of processes, lots of data is getting generated, there you might require that. then machine learning for bottle filling. Okay, so like let us take a Coke bottle filling example. I start. Do you need automation? Yes, of course I need automation. Can you write the rules? Okay, now here is very interesting. I can look at, I can pass some kind of a light through the bottle, and I know the refractive index of the light when there is a liquid inside, and I know the refractive index when there is no liquid inside. So if I send that, I do that simple experiment, I can very clearly see that, okay, the bottle is filled or not filled. So I can write all the rules right away. Because I can write all the rules right away, it's a pure rule-based system. I don't require machine learning here. I am stopping right here itself. Okay. So I hope you all of you are able to understand, the ideas here that, okay, this is how, you take any use case, run it through the flowchart of machine learning, and only if you're reaching to the end of the flowchart, you decide, okay, I'm going to use machine learning for this use case. So I'm just going to take a quick 1 minute break here to understand if you have any doubts. If you have any questions, I'll quickly take some questions and answer now. Otherwise, I'll move ahead for the rest of the presentation. Just giving you a 60-second break to absorb what you have learned so far. Okay, great, awesome.
Yeah. Sir, for particularly disaster management systems, actually deadlocks occurring is it is giving a crucial. Actually, it gives a lot of disaster. So actually, for those such a type of systems, actually we have to avoid the deadlocks by analyzing the resource request priorly. So how actually it is happening in the system. In that case, actually, I think the machine learning may predict beforehand itself, and it can able to avoid that such a type of request granting.
So I let me give you the my rationale behind why I said that. Just tell me this: how many? If I'm doing 100 tasks, okay, can you give me a number of how many times deadlock would occur? Very rough number, like just rough number at the top
maybe
of your head.
2 times. We can roughly assume 2 times.
Roughly 2 times, right? So now, for you should also understand this. Whenever you're using machine learning, there is some additional processing that is happening. That is, before you can do your task, right? Machine learning will take over, and only after machine learning finishes its prediction can the task begin. Okay. So now you have to make this judgment call. Do you want to slow down 98 tasks because you feel 2 tasks are going to stop your process? But again, it depends from case to case. For example, for a personal system, right, there is no point in doing that. But for a disaster management system, like suppose you are using this system in a case where you are controlling the dam gates or something like that, there it might be helpful to wait. So it is all about making judgments based on what is going to happen. So if you feel that even those 2 times when deadlock is happening, those 2 times I'm going to get a very, very important or a very, it is a catastrophe, then I should definitely do that. But for a personal computer system, there is no point in doing that. So that's what you should you should understand where you are doing this and then do that accordingly. I hope I answered your question.
Yes, sir. Thank you, sir.
Sure. Okay. So just moving ahead. So we just did an overview of whether we can use machine learning or not machine learning. A quick overview of the problem solving approach we take when we use machine learning. First thing is identify the business initiative. Why are you doing what you are doing? Okay. In case of agriculture, is it to improve the farmer output or improve the yield? If it is for industry, is it to reduce the number of failure events of machines overall? What is it that you want to achieve? What is the key business initiative? identify that. Many a times people say, okay, I have data, I have data science, okay, combined, these are insights, but they forget why they are doing these things. Very important to do that. Identify stakeholders for whom you are building a solution. Could be the factory manager, could be the CEO, CTO, or things like that. Identify the various entities or the pipelines in this process. Prioritize the decisions over here. Okay, you decide, okay, should I do this, should I not do this? Like, if out of 100 tasks we just discussed, only 2 times deadlock will occur, do we really have to do that? So that prioritization we'll have to do. Then what are the different metrics you will measure? Identify recommendations, map scores to recommendations, that okay, this recommendation has this much impact, and then you decide. Okay, so this might seem a little complicated to you, but summary is this. Whenever you want to use data science, understand the business use case thoroughly, understand the components thoroughly, understand for whom you are building it. Is it for the direct customer? Is it for the factory person for whom you are building the solution? Then only build the solution. Based on each of the choices, your system architecture will keep changing. Okay, now I want to do a simple case study with you, all of you. It will take 5 to 10 minutes over here. Okay, so how many of you have seen Adobe Photoshop? No need to have used it, but have seen the Adobe Photoshop interface at least.
Yes, sir.
Yes, sir.
Okay, great. So if you see the Adobe Photoshop interface, you have close to 30 to 40 buttons that are required to kind of do your photo application. Okay, now Adobe Photoshop has come to you and said that we want to take this Adobe Photoshop application onto mobile. Okay, so when I take an Adobe Photoshop application onto my mobile phone, right, what is the biggest challenge that you see over here?
It will lag the mobile. Actually, it will slow down the system, that mobile system performance.
Great. So good observation. It will slow down your mobile system performance. Why do you think it will slow down?
Because while doing taking of images with Adobe Photoshop, and it is taking pixel by pixel. So pixel by pixel changing, it requires a lot, and after storing the image also, while doing the processing, it is taking lot of time, and after storing also, it is giving in the good amount of memory it is capturing.
Understood. That's a good observation. Any other observations on what would be the other challenge on mobiles? Okay, so on a mobile, typically, how many buttons you can place on a small mobile screen? Think of all the apps you are using, right? How many buttons do you see on your app?
Roughly maximum, actually 5 we can able to use. It may be max 10.
Max 10, 5. Great. Now let us assume that you have the photo on your mobile screen. Along with the photo, right, you can have few buttons. So I would say that you can only put 3 to 4 buttons on your screen in the app. Okay, so now imagine this. For Photoshop, you have got 30 to 40 buttons, but now for the mobile app, you'll have to only show 3 to 4 buttons every time. Okay, now how do you solve this problem overall? Okay, so that is where I will go back to my data. Okay, so typically think of a writing process. After you are writing with a pencil, right, and you made a mistake, what do you use next after a pencil? Do you use an eraser?
Yes.
Okay, now after using an eraser, again you'll use a pencil?
Yes.
Okay, now similarly, for Photoshop, after you are drawing something and you have made a mistake, you use an eraser. So therefore, lot of times when drawing, after drawing, you use a eraser. So when you are using the pen tool, you should be showing the eraser tool on the mobile, because that is what you are most likely to pick. Okay, so if you see this image over here, after I'm using the pen tool, I use the wand tool. After using the wand tool, I use the ink tool. Then again, after using this, I don't know what I'm going to use. So then I'm using a brush tool. After brush tool, I'm using this tool and so on. So I can study patterns of different icons or buttons I'm using. Okay, think of this. After when you're typing on WhatsApp, while typing on WhatsApp, after typing, what is the button you're going to use? It is a send button. After send button, after you send a message, what button you might use? You might want to delete the message overall, right? So there are the human behavior of number of buttons you'll use after each button. When you look at the data, it is very limited. And using that data, you can actually compress huge apps on your desktop into mobile. Okay, now here is a very important thing. This thinking that, okay, this let me look at the data in this manner and let me decide to only put 3, 4 buttons. These decisions only a human will make. Then data science is the tool you use to kind of help you in those decisions. See, what data science does well, it does counting really well. For example, for a human to always count it, okay, this one user in this application, he has used this after this after this. Imagine a human having this job of noting down which button is used next on an application. Like he has a huge big TV, he's looking at 100 people using the app and is noting down each and every person which app is using next and all that. Humans can never do that job. But system, because you are capturing the button clicks and everything, systems can do that job. So whenever you have data and you want to count or crunch your data, systems can do that really well. Humans, from what is crunched and that summarized data that is seen, humans can then do decision making really well, or say that, okay, capture this data and crunch it really well. So therefore, this is the key point behind data science and human intelligence. Humans can zoom out and do abstraction really well. Like you can see 100 things, and when you look at the summary of 100 things, you know, okay, this is the exactly one thing that you can do. But what humans cannot do is they can't go to 100 things at once and try to do counting or things like that. That is not what human brains are capable for. And that's why data science is for data crunching. And whenever you have huge data, and by the way, data science doesn't mean you're doing only programming with Python or things like that. If you're taking data to Excel and visualizing, that is also data science. Okay, so a quick overview of this entire data science process. Again, this is, if you want to go into depth, it takes quite some time to understand each and every one of the steps. This is just to give you the overview of how IoT and data science are merged to provide value to business. So for a business, whenever it happens, this is the complete process that it undergoes. You clearly define the business problem, you set the success criteria, and you define clear data science objectives. So business problem and objective setting is really important. So if you're using an IoT system, what is that IoT system built for? What is it trying to achieve? If you are going for smart lighting, smart electricity systems, then the objective here is to reduce the electricity consumption of a house. So even if after all the smart systems, right, your electricity consumption is still remaining the same, then there is no point having this system at all. Then mapping to the machine learning problem, you have seen that flow chart, right? So you break your huge problem into smaller problems, take those individual problems across the flow chart, and then you try to understand each and every aspect of this. Then data preparation. So you have got these IoT systems, you are getting lots of data, understand the different data points, which sensor is capturing which data, formulate the complete strategy as to how we are going to combine this data overall. And this data has to be stored and used by people. So how we are going to do that? Next, you do the exploratory data analysis, all the data that has been stored, you do the statistical analysis, handle the outliers or errors, and shortlist the different predictive modeling techniques. Do all of this together. So far, you are at some stage, then it comes the basic modeling and evaluation. So when people say I plug data into a data science system, people think that they are doing only this. But if you see, this particular portion of modeling or plugging in the data is only 20% of the work. 80% of the work is here of taking the data, preparing the data, and exploring the data. So when you're using a data analytics system with an IoT system, right, especially, you are spending a lot of time in data preparation and data analysis. And this is the most crucial part that you'll have to focus on. If you are not focusing on this, then you are running into catastrophe. So this is a very important aspect. So let me also go across the complete data science hierarchy of needs. Okay, first thing is you collect the data, then you store the data, explore the data, aggregate the data, and then you kind of learn. Okay, so if you're looking at machine learning, it is almost at the top half of the pyramid. At the bottom half, sensors, logging, external data is where you collect the data. So if you look at this, for an IoT system, the bottom of the pyramid is what your IoT system is. The bottom of the pyramid is how your IoT system is able to, the bottom of the pyramid is how your IoT system stands. So any IoT system you make becomes the bottom of the pyramid, and the data that comes out goes to the database that comes to the middle of the pyramid, and then top of the pyramid is your data science or data analytics system. If you don't have the bottom of the pyramid really set, as to you don't have proper sensors, your system fails. Even if you have proper sensors, you don't have a proper mechanism to store your data, enable a good data flow. Okay, so for computer science, if you're looking at databases, there is something called ETL, extract, transform, load, structured, unstructured data, and all that. So if you're not storing your IoT data properly, again, this entire system is going to fail. So think of it as a pyramid. Like if your base of the pyramid is strong, then the next layer has a strong foundation to stand upon, and the next layer has a foundation to stand upon. If your foundation, the base is weak, then even if your top is strong, and especially if your top is strong, right, because your base is weak, your entire pyramid is going to collapse. So when designing a IoT system with data analytics, ensure that your sensors are well designed, in place well. The data coming out from the sensors is captured properly and is usable and easily stored. And if that system is not completely in place, then you have a major problem. Okay, so again, taking a 1 minute gap over here to kind of understand from you, any questions so far as to the IoT and the data analysis system process. Just giving you 1 minute, think back to what you have listened so far. Any questions, we'll be happy to answer. Okay, great. So now, till now, we have studied the system. We have understood the key aspects of merging the IoT with the data science system overall. Okay, so again, this part is very important. You should understand that the real world machine learning systems is just a very small part of your entire and overall system. Your IoT system is completely here overall. Like suppose your IoT system is coming under data collection and the configuration, serving infrastructure. So this is the place where your IoT system is. The rest of these things is your other systems of process management, analysis, data collection, and everything. Okay, so unless until you have this complete system, and industry can never function. So some people have this misnomer that, okay, I know IoT, no, that is good. Then, I know data analytics, I can mix this both together and I should be able to help my system really well. But that is not the case at all. to help your system really well, you need to have each of these components. So that's why you need system engineers, you need software engineers, you need IoT people, you need data engineer people, you need data science people. All of them coming together will actually help you build this complete system. Any of the people who are supposed to come together don't come, your data analytics IoT system will collapse. So now, piggybacking on what we have discussed so far, let us understand in detail as to why data science projects usually fail. And along with this, I'm going to give you a flavor of why even the IoT projects also fail. Because at the end of the day, IoT is the base of the data analytics project. So why IoT and data science projects typically fail when taken to industry. First thing is 85% of the data science projects fail. That is a business metric. This is a thing that has been brought forth by Gartner, one of the leading consultancy firms in the world. So when they surveyed all the data science businesses across the world, they figured out that 85% of your data science projects typically fail. Now, when 85% of your data science projects fail, what do you do? And why do you think they fail? Reason one is asking the wrong questions. Okay, so let me share with you, a small joke to kind of drive this point as to how, this thing happens, especially, in machine learning. Okay, so once it seems a person had gone to his friend and asked this told this other friend, how many idlis can you eat on an empty stomach? So this was a question posed to the other person. The friend thought about it a bit and said, I can eat 5 idlis on an empty stomach. This friend corrects and says, no, you are absolutely wrong, because once you have 1 idli, your stomach is no longer empty. So therefore, you can eat only 1 idli on an empty stomach. This friend felt, oh my God, this is a very good joke. I should use it on another friend of mine. Okay, so this friend goes to another friend and asks him, how many idlis can you eat on an empty stomach? So this other person said, 6. Then this person said, Are, if you had told me 5, I would have told you a very nice joke. Okay, so if you see here, what is happening is the intent of this question was to elicit a humor, but actually what has happened, the person had became so constrained with the answer that you're getting that they felt that, okay, this is the answer I'm supposed to get with this question. Okay, so asking an absolutely wrong question, right? Another example. It seems once somebody lost a particular gold ring and he was searching under the street light that, okay, my gold ring was lost, and he was searching. And then this person, a passerby asked him, you are searching for the gold ring, where exactly did you fall? Then the person said, it actually fell in my home, but in my home there is no light, and that's why I'm searching under the light over here. Okay, so again, the main problem is you don't shine light onto the major issues or the major components which is going to give you value. You try to shine light on places where it is easy for you. It is harder to search in a dark house. Okay, but it doesn't, it is, at least there is some chance of finding value. If you search under a light where it is easy, but you know that you haven't lost anything there, there's absolutely no point. So what happens is industries ask questions onto the data science or the analytics systems and just completely focus on an absolutely wrong aspect of the picture. Okay, for example, in the agriculture case where you're looking at the soil moisture and you're sprinkling water, what you should be concentrating on? Will you be concentrating on the overall yield the farmer is getting per quarter versus the amount of water the farmer has conserved? Okay, so that is what you need to completely focus on. Okay, so when you are focusing on these aspects of where your main value is, okay, for a farmer, the value is always greater yield. In getting greater yield, if he is able to conserve water, well and fine. So always we go for a very medium pain point instead of a maximum pain point. Okay, so if you are able to attack the maximum pain point, that this sensor is going to increase the yield for the farmer, then your system that you build step by step is going to be very strong and very useful for the farmers, because you are going to ask the right questions at every step of the way. When you say, okay, I'm building this sensor, how is this sensor helping the farmer to increase his yield? And based on that, the entire system is helping. But if you think of the water, like I have to conserve water overall, then you will be conserving water. And for the sake of conserving water, sometimes you don't supply water to the soil when actually you require the water there. So again, those decisions happen. So main reason always is you ask the wrong questions, you focus on the wrong thing, and your entire IoT data science project fails. Second thing is lack of support by stakeholders. See, in industry, there are lots and lots of wings, and one of those wings is IoT and data science. If the industry, like if you are saying to the factory operations head that I can reduce, okay, you know what, I can reduce the amount of machine failures from 4 per quarter to 0 to 1, but for that, you will have to cooperate with me on these things. Sometimes they agree, other times because they are so used to working in a particular way, they are resistant to change. Okay, and whenever there is a resistance to change, a project is doomed to fail. So therefore, whenever you have any kind of lack of support from your stakeholders, right, your project is doomed to fail. So therefore, it's very important to talk to your stakeholders, explain them that, you know, it's going to take time. Another thing, what happens is people expect some instant results. Like they say, okay, data science system is set up, IoT is set up, I'm going to immediately see profits. Patience is needed. So once you set up the entire IoT and the data science project, it takes good 6 months to see value. And sometimes businesses don't have the patience to wait out and see the value in this entire life cycle. Poor data availability. So again, one thing is because your data is poor, sometimes your projects fail. IoT has a different problem. Data is available, like data is generated, but it is not stored properly. Okay, for example, there are this lots of tools that can do this transform, extract, and load, like Amazon Redshift, in my opinion, Amazon Redshift, Google, I forget the name, and there are lots of companies like Cloudera and all that, which provide solutions for this transform and load. So whenever there is, if you don't have a proper system set up to capture all the IoT data in a proper format, which can be used by the data scientist, again, your project is doomed to failure because your data availability is extremely poor. Okay, so in summary, right, if I'm looking at the different aspects of all the layers that I've seen, if I'm looking at the IoT, if I'm looking at data science and everything that I'm trying to look at, right? So data science at its core, like if you strip away all the complexities, it is just getting insights from data and providing value to the stakeholder. Now, this second part is where people generally miss. So what they understand is, okay, data science is something, I plug it to my data, I get some insights. But if those insights don't help your company or your stakeholder, right, then your data science thing is always in trouble. One example, if Google Maps, right, if the data science in Google Maps is not helping a person in reaching the destination faster or planning the route without any roadblocks, then the Google Maps is failing in its endeavor. If you are able to say that, you know what, whether it's a roadblock, I'm able to predict a roadblock, those are all secondary things. Primary, Is this person reaching the destination or not? Let us take it for Zomato, Swiggy. Person reaching a destination fast could be something that yes, they are interested in. But at the end of the day, what they want to measure, they want to kind of get huge number of orders. So your data science system there is going to be built on the how many orders can I place in a given amount of time? How many orders can I deliver in a particular amount of time? For example, you are placed an order and the order is expected in 20 minutes. Then there is another order which is kind of present 10 minutes in the opposite direction. Then what this person will do is he will go 10 minutes in the opposite direction, deliver that order, and come 20 minutes behind and then deliver your order. So that is how the system is, because within 40 minutes you are going to deliver two orders, which is 20 minutes average per order. Instead, if it goes 30 minutes, then he's coming back those 30 minutes again and adding again 10 minutes. It is somewhat coming to 70 minutes, which is 40 minutes per order. So Zomato, Swiggy might make you wait for additional few minutes to ensure that the average amount of time per order is going to get reduced. So if you see, whatever you are planning to kind of cut down or whatever you are planning to reduce, what is the objective you are looking at? If you are focusing on that objective, right, based on the focus of your given objective, your data science is changing. So alignment to business goals, right? So every business you'll have to kind of understand what is the North Star metric you are going to look at. What do you mean by North Star metric? North Star metric is something that they want to measure and move across. So let me give you one example of a North Star metric. So for OYO rooms, right, for people like hotels, the North Star metric is this: how many times the room is getting booked in a particular month. Okay, and every strategy, every aspect is going to be focused on only that thing. If irrespective of how much hard work you're putting, if that metric is not moving, then there is nothing you could do. Otherwise, you will have to keep focusing, keep moving things ahead so that you are moving that particular business metric. Don't get driven by buzzwords. So a lot of times what happens is there are this lot of buzzwords being thrown across with data science. For example, they say data science is this, data science is that, data science is this complicated thing to do. Overall, data science is statistics in action. There are lots of definition, lots of buzzwords. But true data science, remove all the buzzwords, go deeper, think deeper, see what you really need to do. Think of what you want to achieve as part of your data science initiative. Based on what you want to do and what you want to achieve, that is your data science. People keep saying data science means only programming on Python, programming on R, and things like that. But actually, data science is if you're taking data and you opening up an Excel and doing some things on Excel, that also is data science itself. Like if you're opening an Excel sheet and doing some calculations, you're doing data science. At the end of the day, data science means solving problems. So all industry says we don't bother about how they solve the problems. If they're solving the problems, that is data science for me. So you kind of need to, be very, very and sure about this and ensure that the students also are able to get this particular insight with respect to data science. Okay, there are lots of reasons to fail. Okay, we have gone through many multiple reasons. Try to be aware and be alert with respect to each of these reasons. Okay, so now I would like to open 15 minutes for any question answers overall. Okay, so I want any doubts, any questions on data science that you have. For the next 15 minutes, I'm very happy to answer.
Thank you, sir. Dear participants, please go ahead with your queries. Any queries from anybody?
Okay, so what I would suggest all of you is to always when teaching IoT and data analytics to your students, um, as you are teaching the basic aspects, technical aspects, also talk about the softer aspects that we discussed, because these are the softer aspects that company wants typically for people to kind of incorporate, and company wants these softer aspects to be used always. And because these software aspects are to be used for the various companies, sometimes people companies come back and say that, like when we spoke to lots of companies, and every time they came back saying that if people are able to solve problems using data science, that is sufficient. No need to have any fancy knowledge, fancy tools, etc. Okay, so if there are, I'll just wait for 2 more minutes. If there are no more questions, right? Thank you for this opportunity, and thanks a lot for all the interaction and being a very great audience. I enjoyed giving this presentation to you. I hope you also enjoyed this presentation, and you knew something little more than what you knew before this presentation overall. So thank you very much, and I hope this presentation from my end was useful. Any feedback, feel free to pass it on, and I'll use that to improve in my next presentation. Thank you very much.
Sure, sir. Thank you very much, sir, for providing your valuable information and your support. Dear participants, next session will be continued from 11:45. Take a break for 15 minutes. Thank you.
Thank you, everybody.
Thank you, sir.